All right. So what does the problem tell you? This problem tells you that 50 numbers are rounded off. Okay, numbers are rounded off to the nearest integer, and then summed. The individual round of errors are uniformly distributed between 5 and 1.5. What is the approximate probability? Probability that the resultant sum differs the exact sum by more than 3. Okay. So this is obviously going to be an application of central limit theorem. Okay, so what we want to find, we would like to find the total error from the sum of 50 numbers um, okay, what is the probability? So let me see. What is the probability that the resultant sum differs by more than 3? Okay, so we like to find the probability that total error from the sum of 50 numbers more than 3. We would like to find probability that the total error from the sum of 50 numbers is more than 3. Okay. Um, so we go through the usual trick, which is let us define this xi. Okay, error from the ith term and it is given that each of these xi's are uniform between negative 1/2 to 1/2. You can check that if that is the case, then expectation of xi is equal to 0, and a variance of xi which is expectation of xi square minus expectation xi whole square, that is going to be essential expectation of xi square, because expectation xi is 0, which is integration of x square times the PDF of this uniform. So the PDF of this uniform is 1 over 1 up minus 1 up, which is 1. So 1 over 1, and that is valid when negative 1/2 less than x less than 1/2. Anyway, so you multiply this PDF, which is 1 dx, that is negative 1 half to 1 half. And if you complete the integration, I guess you are going to get, so 1/8 plus so 1/3 of 1/8 1/8, which is going to be 112. Okay. Anyway, so your mu is 0 and sigma square is 1/12. Now what do you want to find? We want to find the probability. So we want to find that probability that sum of the errors, absolute sum of the errors, which is summation xi is equal to 1 to 50, right? So this is the total error more than 3. Okay. This is what you want to find. You want to find the probability that the resultant sum differs from the exact sum, which means the error. Okay. Sum of the error is more than 3, and this xi is an error from each term. So total error is going to be summation xi I is equal to 1 to 50. That is more than 3. This is what we want to find. Is the setup clear? Whoever was asking these problems, there are a lot of people asking this problem, problem number 6. To them, is this a setup clear that you want to find probability summation xi I is equal to 1 to 50 bigger than 3? Okay. Okay. And after that, we just use the usual trick of the central limit theorem. So mu is 0. Okay, so this probability is approximately going to be that probability mu is 0, right? But still I am writing this. So summation xi I is equal to 1 to 50 minus 50 times mu divided by sigma square root of 50 bigger than 3 minus 50 mu, excuse me, uh, 3 minus 50 mu divided by sigma square root of 50. And this is going to be probability that now you know the trick that this thing here is approximately normal distribution. So this is approximately a normal 0 1. Okay, if you say that this z follows normal 0 1, then this probability is nothing but the absolute value of this normal distribution bigger than 3 over, because 50 mu is 0 anyway. Sigma is square root of 1 over 12 and 50, so basically 50 over 12, square root of 50 over 12, which is probability absolute value of z bigger than so if I, okay, so what do I do here? 3 over square root of 50 over 12, so square root of 25 over 4 is 5 over 2, and then 2 over 3, okay, which is probability absolute value of z bigger than 6 square root of 3 divided by 5 square root of 2. Okay. So what is that? 6 square root of 3 divided by 5 square root of 2. So let me do 3 over 2, which is 1.5, then square root, which is that, then multiply that by 6 and divide that by 5. So you get 1.5 1.4697. Let's 1.7. Let's say okay. So this is probability absolute value of z bigger than 1.4697. And what is that? Let me find that calculator. Excuse me. Okay. So we want to find the normal distribution, absolute value of the normal distribution bigger than 1.4697. Okay. 1.4697. Um, or 697, which is 0.14164. So if you draw a picture, okay, so what is happening here? Absolute value of z is bigger than 1.4697. So suppose you have 1.4697 here. That we want absolute value of z bigger than that, which means we want this area plus less than negative 1.4697. This area. Okay. So if you add both of these areas, you will get 0.14164. Actually, from the calculator also say it's the addition of those two shaded region, which is 0.14164. Okay, so a lot of people have requested this problem. Let me know if you have any question about the whole process. So can anyone tell, like whoever requested this problem, if you can unmute your mic and let me know your opinion. Was the okay? Since I cannot see you, I do not know whether you are understanding or not. But anyway, if you do not ask anything, so I will move to the next problem. The next problem was problem 8 from the same chapter. What is this problem about? I think I did the same problem, or at least like very similar problem in my lecture. Which says that lifetime so x is the lifetime of a battery. It is given that expectation of x, that is the average lifetime, expectation of x is equal to 5 weeks, and standard deviation is 1.5 weeks, which means the variance of x is 1.5 square. and often failure, uh, it is immediately replaced by a new battery. Approximate the probability that 13 or more batteries will be needed in a year. Okay. The probability that 13 or more batteries in a year. Okay, so we are going to follow the same technique that we did in the class, which is suppose Xi is the lifetime of the ith battery. Okay, and as I explained in the last lecture, that we need 13 or more battery here if the total lifetime of first 12 batteries, the first 12 batteries is less than 52 weeks, because 1 year is equal to 52 weeks, right? So essentially we want to estimate the probability that summation xi is equal to 1 to 12 is less than 52. Okay. So is this setup clear? And it is also given to us. It is given to us that mu is equal to 5 and sigma is equal to 1.5. Okay. That is given to us. And you want to estimate the probability that summation xi is less than 52, which is going to be probability that summation xi is equal to 1 to 12 minus n times mu divided by sigma square root of n is less than 52 minus n times mu divided by sigma square root of n, which is approximately equal to probability. Now, as I keep saying, that this guy here is approximately normal distribution, mean zero variance 1. So if I said that Z follows normal distribution with mean zero variance 1, and then this probability is Z less than 52 minus n mu, which is 52 minus n is 12 times 5, sigma is 1.5 and n is 12. Okay. That is going to be probability that normal distribution is less than 52 minus 60, which is negative 8, divided by square root of 12. So if I take out 4, it will be 2. So 3 times square root of 3, which is so 8 over 3 square root of 3, right? So 3, take the square root, multiply by 3, 1 over x times 8 which is 1.5396. Okay, 1.5396. So that is probability that z less than negative 1.5396, which is okay. So it's less than, right? So it's less than negative 1.5396. The probability is 0.06183. Okay, 0.06183. All right. So whoever requested this problem, do you need any more explanation? Okay, in that case, I'll move to problem 57 from chapter 4. By the way, I wondered, is my screen visible and am I audible at all? Because I do not see any input from your side.
Audible, sir.
Okay. The next problem is problem 57 from chapter 5. Okay, what does this problem tell you? So this problem tells you that we have two distribution functions. One second. This is chapter 6. No, not chapter 5, right? No, this is chapter 4 actually. Okay. So you have two distribution functions. Okay. So fx and fy, sorry, fy are two CDFs. And b bigger than 0 and a are two constants. Okay. It is given that this fx at x is equal to fy at x minus a over b, and we want to write expectation of x, variance of x in terms of expectation of y and variance of y. Okay. How do you do that? So first of all, from this thing, okay, erase that. Okay, the point is that this fx, right? So this fx x by definition is probability that this random variable x is less than equal to some real number x. Okay. The convention is that these uppercase letters are used for random variables. And these lowercase letters are for real numbers. Okay, this is the convention all around the probability theory. So you know these variables, like if I write fx of say 0.5, right, that would imply I'm talking about probability that this random variable x less than equal to 0.5. Okay. Anyway, so this is the definition of fx, and similarly fy at x minus a over b is going to be probability that the random variable y is less than equal to x minus a over b. Okay. Which is probability that by plus a less than equal to x. Okay. Because this b is positive, right? So since this b is positive, it is already given in the problem actually that b is positive. Since b is positive, when you multiply both sides of this inequality by b, the inequality will not change. So we will have by less than equal to x minus a, and then by plus a is less than equal to x. Now, in the given problem, it is given that this guy fxx and fxx minus a over b, those two are equal, right? So that would imply that we should imply that probability x less than equal to x is same as probability by plus a less than equal to x, right? In other words, x and by plus a has the same CDF, right? That is x and by plus a. They are having the same PDF. Same CDF. Now, if two random variables are having the same cumulative distribution functions, then they are the same random variables. So it should imply that x is equal to by plus a. Okay. This is essentially the answer to the whole problem. If you have understood up to now, next step is easy. That we want to find expectation x and variance x in terms of expectation y and variance y. So does anyone have any question how I arrived at this conclusion that x is equal to by plus a? So you have two random variables x and y are related by that x is equal to by plus a. Now the part A of this problem asks you to find the expectation of x, which is going to be expectation of by plus a, that is expectation of by plus expectation of a, which is b times expectation of y, because you know that if you have expectation of a constant times random variable, you can pull that constant outside, and expectation of a constant is that constant back. So expectation x can be written as b times expectation y plus a. And part B was about the variance. The variance of x is a variance of by plus a. Now, variance of a random variable plus constant is same as the variance of that random variable, which is variance of by. I will explain this step a little bit more after I complete writing this, and which is equal to now variance of constant times random variable. If you take the constant outside, it will to come out as a square. So it's going to be b square times variance of y, and I explained this step before. Now, if you are wondering about this question mark step, like how come variance of by plus a is same as variance of by, here is the explanation, and this is also one line proof. So variance of by plus a, by the definition of variance, is going to be expectation of by plus a minus expectation of, this is the original definition of variance, by plus a whole square, okay, which is expectation of, now this a and a are going to cancel. You will see in a moment that this is going to be by plus a minus expectation of by minus expectation of a, but expectation of a is simply a, you know that, the whole square. Now what you will see that this expectation a is simply a, that we cancel with this a, and you get expectation of by minus expectation of by whole square, which is variance of by. So variance of a random variable plus any constant is same as the variance of the random variable itself. So if you add a constant like variance of 2x minus 3, same as variance of 2x. Anyway, so this is the answer, that expectation x is b times expectation of y plus a, and variance x is b square times variance y. Okay, so let me know if you have any question about this last problem. Okay, problem 8.6 is done. Problem 56. Problem 56 is simple. The Markov inequality and everything. I will only explain the part C of problem 56. Problem says that x is the test score of a random chosen student. Okay, and it is given that expectation of x equal to 75 and variance of x is 25. Then the problem asks you how many students would we, so okay, how many students would have to take the test so as to ensure with probability at least 0.9 that the class average would be within 5 of 75. Okay. To do this problem,
Sir, here what is the meaning of within 5 of 75?
which means the class average would be within 70 and 80.
Okay, sir.
So 75 plus minus 5. Okay. So let n is equal to the number of students taking the tests, right? Okay, so after this problem, I do not think I will have any time to do anything. So then you can start taking the quiz, I think. But anyway, so n is the number of students taking the test, and xi is the score of the ith student. Okay, then the class average. Okay, then the class average is going to be simply 1 over n summation xi, right? I mean, we do not need to know any mathematics for this. So xi is the score of ith student. You take the sum of all scores divided by the total number of students. You get the average score of the class. Let us denote this by x bar. Okay. So this x bar is the class average. This is actually a standard notation. We will learn in the next lecture. X bar is called the sample mean, and we actually are dealing with the sample mean. Okay. Now, what we want to find? We want to find. We want to find n such that the probability that this class average is within 5 of 75, which means probability that this class average is in between 70 and 80 is at least 0.9. At least 0.9. Is that what it's saying, right? So this problem is saying that with probability at least 0.9, the class average will be 5 of 75, which means the probability that this x bar will be 70 to 80 with at least 0.9. So what is the value of n should be such that we get this thing, right? How to do that? This is going to be actually very simple computation, but before doing that, let me observe few things about this x bar. First of all, expectation of this x bar. This x bar is 1 over n summation xi. So expectation of this x bar is going to be expectation of 1 over n summation xi I is equal to 1 to n, which is, so you can take this 1 over n outside and then take the sum, push this expectation inside the sum, expectation of xi I is equal to 1 to n, because expectation is linear, you can push it back and forth within the sum itself, which is 1 over n times summation expectation of xi. Expectation xi is given as 75. That is true for all xi, right? So for random student is 75. So this is going to be you are adding up 75 n many times I is equal to 1 to n. So which is 75 n divided by n. So that is simply 75. Okay. In fact, you can prove that if expectation of xi is equal to mu, then expectation of x bar is also going to be mu. This is what we have just proved. Like we had mu equal to 75, that's why we get 75. But otherwise, if each expectation xi is equal to mu, then we will be adding up mu n many times. This will be n mu over n, which is 75. I strongly recommend you to remember this fact, because we will be using this fact again and again in the upcoming lectures. Okay, and the next thing we would like to calculate is the variance of x bar. What is variance of x bar? Variance of x bar is going to be variance of 1 over n summation xi I is equal to 1 to n. In that case, so when you pull out this 1 over n outside the variance, you get 1 over n square, and you get a variance of summation xi. I is equal to 1 to n. Now assuming that these xi's are independent, okay, what am I assuming here? Assuming that these xi's are independent, what is xi? Xi is the score of the ith student, okay. So assuming that the score of the ith student score of the ith student does not depend on the score of the jth student. So if xi's are independent, I can push this variance inside the sum without the covariance terms, right? Of course, if they are cheating, they are looking each other's answers, then these scores are not going to be independent. One scores will be dependent on others. So assuming that there is no cheating happening in the exam, and you can assume that scores of the ith student is independent of the score of the jth student, we can put the variance inside the sum. Now variance of each xi is again 25. It's given to us. So variance of each xi is 25 given to us. So essentially, we'll be summing up this 25 n many times, right? So n square times summation 25 I is equal to 1 to n. So we're adding up 25 n many times. So it's going to be 25 n over n square. That is 25 over n. In fact, we can prove that if variance of each xi is equal to sigma square, then variance of x bar is going to be sigma square divided by n. Once again, I also recommend you to remember this fact that variance of the sample mean is going to be population mean divided by n, and something mean expectation of sample mean is simply population mean. Okay, someone is texting. No one is texting. Anyway, so why am I doing all this? This will be clear now because I'm going to use the simple Chebyshev's inequality. So what do I have here? So I have probability x bar between 70 and 80. So this can be written as okay. So probability 70 less than x bar less than 80. That is going to be probability. So x bar minus 75. Okay, why am I subtracting 75? Because if you want to use Chebyshev's inequality, you have to subtract the mean of the random variable, right? And mean of x bar is 75. We just saw it. So you subtract 75 from the whole inequality. The left side is going to be -5, right side is going to be 5. So essentially, we are finding the probability that the absolute value of x bar minus 75 less than 5. Okay. Now, how do you use Chebyshev's inequality here? Because Chebyshev's inequality tells you that probability x minus expectation of x bigger than sigma, right? So bigger than epsilon. So bigger than epsilon is less than variance x over epsilon square. Okay. So probability that x minus expectation x absolute value bigger than epsilon is less than variance x over epsilon square. But I have less than 5, right? So I have less than 5. What do we do? Very simple thing. I have also demonstrated this before. We look at 1 minus probability x bar minus 75 bigger than 5. Now, what is probability x bar minus 75 bigger than 5? So probability absolute value x bar minus 75 bigger than 5 is going to be less than, by Chebyshev's inequality, variance of x bar divided by 5 square. The variance of x bar is 25 over n, so it's going to be 25 over n times 25. Why am I writing 7? 25 over n times 25, which is 1 over n. Now, probability x bar minus 75 bigger than 75 is less than 1 over n, but since I have a negative sign here, this inequality will flip. Actually, this inequality will go like this: bigger than equal to 1 minus 1 over n. Okay, so we are one step away from the final answer. What do we want? we want this probability that x bar between 70 and 80 is at least 0.9. This is what we want. Right? And we figure out that x bar between 70 and 80 is at least 1 minus 1 over n. So if you want our conclusion to hold, we need that 1 minus 1 over n is bigger than 0.9, right? Because if 1 minus 1 over n is bigger than 0.9, only then we have x bar between 70 and 18 bigger than 0.9, which is what we want, right? We want x bar between 70 and 80 bigger than 0.9. So 1 minus 1 over n bigger than 0.9 would imply that 1 over n less than 0.1, and that would imply that n is bigger than 10. So that is the answer. That we need at least 10 students to take the test so that the class average will lie between 70 and 80. Okay, so let me know if you have any. What's that? Hello? Someone is trying to ask you a question. Gopana Jasubant Kumar. By the way, the quiz is already up online in the assignment tabs. If you want, you can start taking the quiz. In the meanwhile, if you have any question, you can also ask. So I will stop the recording now.